Calc BC 4-6 office hours. So this had a little more extra review of polar on the front, but then it had a bunch of integration on the back. So you can check your answers real quick. These are just the answers. I'll be going over the work for these. So pause it if you need to. Okay, so those are all the polar ones. And then on the back, and I posted these online, so you should have been able to check these already, hopefully, too. Multiple choice, but you gotta show work. Now, this is all integration. And so we're just trying to get some practice with integration because we're gonna bring integrals into our polar problems in the next lesson. So this is an opportunity just to kind of practice some of those integration skills. Pretty much, it's all AB stuff. So a lot of probably U-Substitution, other things. Got a couple kind of problems here, working backwards from the second derivative to the first to the original function with some initial conditions. So you're finding the C values along the way. 17, kind of the same idea, tied to motion. So let's take a look at these. We'll do a quick review of polar on the front. So find the maximal radius and angles where they occur. Find the smallest positive angle where the radius is maximized. So I think the answer to A is going to pretty much give us the answer to B. I'm gonna do a quick sketch. So I'm just going to do a quick sketch of this. This is a rose curve with a radius of 2. I was cutting grass earlier, so I don't know if my fingers look green. It's kind of weird getting close-ups of my hands. Okay, so rough sketch, light dashed curve for a circle that is going to fit the side of. We want to figure out what are the tips of the flower going to be plus or minus 2 equals 2 sine 3 theta, which is going to be plus or minus 1 equals sine 3 theta. And then so 3 theta equals pi over 2 plus pi k. So theta equals pi over 6 plus pi over 3k. So theta equals pi over 6, pi over 2. And the 3 pi over 6, 5 pi over 6. Now this is going to, I think that's all we need because this has 3 petals. Odd number, so you're just going to get 3 petals instead of 6. The second set of 3 petals, there are 6, are right on top of the first one, so we just don't bother trying to graph those. So I'd graph pi over 3 and 2 pi over 3 first, and then cut those in half to get pi over 6, pi over 2, and 5 pi over 6. And I draw them all the way through because some of the petals have negative radius, so just makes it easier. And the other in between angles I'd want anyways, just because they're going to be the edges of the petals. So the first one's going to start at pi over 6. So it's going to be the first petal, and then it's going to go into pi over 2, but it's going to be negative petal. So this is the second petal, and the third petal is going to have positive radius again at 5 pi over 6. It's going to look like this. Okay. So that could help us, just so trying to find maximum radius. Well, maximum radius is going to be 2 for sure. It's going to be the tips of the petals, and we've already kind of found these. I'm going to do the work again as if we were trying to find them, and then we're going to find the smallest positive angle with the radius maximized, which I believe is going to be pi over 6. So If we're looking for the max radius, we can treat this as a EVT problem. So we're going to find r prime drd theta, which is going to be 6 cosine 3 theta. We're going to set it equal to 0. So it's going to be cosine 3 theta equals 0. So it's going to be 3 theta equals pi over 2 plus pi k, and theta equals pi over 6 plus pi over 3k. And we're looking for all the values between 0 and 2 pi. So that's going to be pi over 6, pi over 2, 5 pi over 6, and we got another 2 pi over 6, 7 pi over 6, 9 pi over 6, which we could say is 3 pi over 2, and 11 pi over 6. Those are your critical points. So then we could make a table with the endpoints, critical points. All right. So if we plug these into the radius, 2 sine 3 theta, if we plug 0 in, you get 0. Pi over 6 is going to be pi over 2, that's going to be 2. Pi over 2 is going to be 3 pi over 2, which is going to be negative 1, it's going to be negative 2. 5 pi over 6 is going to be 5 pi over 2, which is the same as pi over 2, which gives you 1 times 2. 7 pi over 6, I mean, you could kind of start to see negative 2, 2, negative 2, and this one's going to be 0. So here's your max. And then we have our min values, which are also tips of petals. So we say the max radius is 2 at angles theta equals pi over 6, 5 pi over 6, and 3 pi over 2. And B says, well, what's the smallest positive angle with the radius of maximum? Right there, theta equals pi over 6. So there you go. All right, number 2, find the slope of the tangent line at a certain angle and find the equation of the tangent line. Okay, so that stuff will kind of work together. Let's draw a sketch real quick. This is not a cardioid, it's not a rose curve, it's not a circle. It's a limacon, either with inner loop or convex. I'm going to just make a quick table, and I'll figure it out pretty quickly from that without having to memorize extra information about how to categorize these. So 0 in here, it's going to be negative 1, 1, 3, 1, and negative 1. It's going to be sideways, and the biggest side is to the left side, so you might give yourself a little more room over here. Okay, so 0, negative 1, this is by inner loop, because it's backwards. And pi over 2, 1's here, and pi 3 is here, and 3 pi 1 here. So yeah, this is going to be inner loop. So it's going to go like this. It's going to kind of look like a cardioid, but then it's going to come in here and loop in like that. So there you go. I'm trying to find the slope of pi over 3. Now, pi over 3 would be like right here. So I'm kind of thinking it's like right around there. It might be a really negative slope, or it might be like a vertical slope. It could be vertical. I don't know. But that's what we're looking at. Well, actually, hold on a second. This is the first spot, 0. And pi over 2 was here. Pi over 3, yeah, I think that could be pi over 3. So, and this graph is going to go like this. It's going to start here and go this direction. That was 0. That was angle 0. That's angle pi over 2. Pi over 3 would be in between them, so probably that. Okay, so let's figure this out. We need a point and a slope. X equals r cosine theta, which is going to be 1 minus 2 cosine theta, and y equals r sine theta. So it's going to be parentheses 1 minus 2 cosine theta sine theta. And so the slope is going to be dy dx, which is going to be dy d theta over dx d theta. And this isn't a special case, so we got to just do it all the way out. So 1 minus 2 cosine theta times derivative of sine is going to be cosine theta plus sine theta times derivative of what's inside. There's going to be positive 2 sine theta. And that's the top. The bottom's going to be 1 minus 2 cosine theta negative sine theta plus cosine theta positive 2 sine theta. Okay. So then we're going to plug theta equals pi over 3 into that. And I'm going to just start to do the work and write down. So cosine pi over 3 is 1/2 times 2 is 0. And cosine of pi over 3 is 1/2. Right? Plus sine pi over 3 is root 3 over 2. And then that's going to be 2 times root 3 over 2. And the bottom down here, we can get 0 again, times negative root 3 over 2 plus 1/2 times 2 root 3 over 2. So those go away. Here the 2's cancel and the 2's cancel, and we get 3 over 2 and then root 3 over 2. It's going to be 3 over root 3, which is the same thing as 3 root 3 over 3, which is root 3. So that's your slope of your tangent line. Okay. Now we need the equation of the tangent line. So we need the x and y coordinates. Now, by the way, that's a positive slope. I mean, I guess it could have been somewhere around there, you know. Not quite. We're going to find the x and y coordinates right now. So x at pi over 3 is going to be 1 minus 2 times cosine of pi over 3 is 1/2. And then cosine of pi over 3 is 1/2. But that's going to give you 0. And the y coordinate is going to be 1 minus 2 times cosine pi over 3 is 1/2. And then sine of pi over 3 is root 3 over 2, but that's going to give you 0. So this is actually at the origin. Kind of crazy. I mean, I guess, you know, this was 0, this was pi over 2, pi over 3, somewhere in between. I mean, it could have been right where it was going through the pole. So the equation of the tangent line is going to be y minus 0 equals root 3 times x minus 0. I mean, you could write in point slope form if you want, but you could easily write it in slope intercept. So kind of interesting. Okay. Find the slope of the tangent line at the pole. So this time we're specifically looking for the pole. This is some kind of limacon, not a cardioid, not a circle. Let's see, it's going to be different than the last one. Slightly, it's almost the same. I mean, this is 1 plus 2 cosine theta. The last one was 1 minus 2 cosine theta. So it might look like this one, but flipped to the other side. So 0, pi over 2, pi, 3 pi over 2, 2 pi. So plug 0 in there. Cosine of 0 is 1, so it's going to be 3. And pi over 2 is going to be 1. Negative 1, 1, 3. It's bigger to the right. And so 0, 3, pi over 2, 1. Pi negative 1 has that in a loop. 3 pi over 2, 1. So yeah, it's going to look like that. Okay. And so we're trying to figure out what's the slope of the pole. So it goes through the pole twice. So I think it's have that slope and that slope, positive and negative slope. It might be the same numbers. I don't think they're necessarily perpendicular, but I think they're kind of coming at the same angle, one positive, one negative. So this ended up being a limacon with an inner loop, which I don't memorize those. I just kind of knew it wasn't going to be cardioid. And I think it's either inner loop or it's convex, and calculate a few values I could do anyways and figure it out. So we need the slope. So we got to figure out when does it hit the pole, which was none of the common values. So we got to figure out when does it hit the pole. And that's going to be when r equals 0. So we're going to solve that trig equation. Alpha equals pi over 3, quadrant 2, quadrant 3. So theta equals 2 pi over 3 and 4 pi over 3. So those are the angles that it happens at. Now, we're going to do dy dx. Now, we can use a shortcut here because this is at the pole. At the pole, it was tangent theta. You guys remember that? I mean, you could do it all the way out. But this is going to save a good amount of time. So dy dx at theta equals 2 pi over 3. Sine of 2 pi over 3 is going to be root 3 over 2 positive, the second quadrant. And cosine 2 over 3 is going to be 1/2. It's going to be negative in the second quadrant. So it's going to give you negative root 3 for the slope at theta equals 2 pi over 3. And we can see if that makes sense. Starts here, goes around like this, and then comes in like this. So it's coming through here at 2 pi over 3, and that's a negative slope for sure when it's coming in there, that first angle. And then the second angle is going to be at 4 pi over 3. That should be the positive one. I'm assuming it's going to end up being the same positive root 3 instead of negative root 3. So 4 pi root 3, that's reference angle pi over 3, quadrant 3. So sine is negative root 3 over 2, and cosine is still negative 1/2, and you get positive root 3. So that's using that shortcut for the pole. Dy dx ends up just being tangent. You do it the long way, same answer. If you look at my solutions, my work online, I did it the long way, and I got the same answer. So I think that shortcut's worth it. It comes up every now and then. I think it's worth it. So now for a little integration review, a bunch of Calc A/B stuff. I'm going to be doing a lot more integrations soon. So this is your opportunity to sharpen those skills. Gosh, it'll work even if it's now here. What you could do is you could do like a U-Substitution. I think you could avoid it on these ones. Du equals 3 dx. I don't want the 3, so divide by 3. So I get 1/3 sine u du. That gives you negative 1/3 cosine u plus c. And that gives you negative 1/3 cosine. Replace the u back with the original x expression plus c. So negative 1/3. So that looks like A. Okay. And so let's see. So a lot of U-Substitution. I mean, I even wrote that here. This one is velocity. We're going back to position. So position is the integral of velocity, which is going to be the integral of sine 2t. Now, I mean, you could do U-Substitution on this one, but I think you could pull this off in your head. Like, it's going to be negative cosine 2t. It's going to give you an extra 2 that you don't want, so you put a 1/2 in front, right? And then they give you initial conditions so we can find the c value. So s of 0 equals 1/2. Cosine of 0 is 1 plus c, and it should come out to 0, so that means c should equal positive 1/2. So your answer should be, for s of t, should be negative 1/2 cosine of 2t plus 1/2. So negative 1/2 cosine 2t plus 1/2. So I think it's that one right there, D. Okay, number 6. Remember this is secant squared like that, tangent squared. So is the inner function the secant or the tangent? Whichever one you pick for u should be the derivative of it should be the other thing. So I think we're going to go with u equals secant because the derivative of secant is tangent squared. Whereas if you picked tangent, the derivative of tangent secant tan, that doesn't really work out as nice. So this is going to be u squared du. And so it's going to be u cubed over 3 plus c. So it's going to be 1/3 secant cubed plus c. 1/3 secant cubed plus c. Oh, shoot. Tangent. I messed up. Tangent. The derivative tangent is secant squared. So there we go. I was going too fast. Derivative secant tan. I think I even said that. But tangent should be the inner function because the derivative tangent is secant squared. And that's the other thing there. So the answer is going to be A. All right. Okay. U equals the inner function. Du equals 2x dx. I don't want the 2. So I'm going to rewrite this as 1/2 square root of u du, which is 1/2 u to the 1/2 du, which is going to be 1/2. Power will bump it up 1, divide by the new exponent, plus c. So it's going to be 1/3 x squared plus 1 to the 3/2 power plus c. 1/3 x squared plus 1. So that's c. Okay. Next one. U equals x squared plus 2, du equals 2x dx. I don't want the 2. So this is going to be 1/2 u squared du. So that's going to be 1/2 u cubed over 3 plus c. So it's going to be 1/6 x squared plus 2 cubed plus c. Okay, next one. U equals 4x cubed plus 3. Du equals 12x squared dx. I don't want the 12. So it's going to be 1/12 1 over the square root of u du. So that's going to be 1/12 u to the negative 1/2 du. So that's going to give you 1/12 u to the positive 1/2 divided by the new exponent plus c. It's going to be 1/6 square root 4x cubed plus 3 plus c. Don't forget the plus c. All right. Okay, I think here u is going to be tangent 3x, and du is going to be 3. Derivative tangent is secant squared. And then you got to do a chain rule there. And I don't want the 3, but the secant squared works perfectly. So that's going to be 1/3 e to the u du. So it's going to be 1/3 e to the u plus c. So it's going to be 1/3 e to the tangent 3x plus c. Okay. All right. Next one. Could we say u equals x to the 3/2? I think that's better than x cubed. Du equals 3/2 x to the 1/2. That looks good. But I don't want the 3/2. So it's going to be 2/3 because you're dividing by 3/2 e to the u du. It's going to be 2/3 e to the u plus c. It's going to be 2/3 e to the, I mean, you could change it back to the square root of x cubed if you want. Okay, 12. Now 12, if you set what's inside, which is usually a good call, it doesn't work out so nice because you still have this x here. So you're like, well, what do I do? You know, you're like, well, what we do, see, I mean, if we do this right now, we're going to have negative x squared of u du. Well, that's no good. You can't have x and stuff. But what we could do is we could say, oh, well, x equals 3 minus u, right? And plug that in for that x. So it's going to be 3 minus u. Now the square root of u, I'm going to change to 1/2. And then I'm going to distribute this. So I'm going to get 3u to the 1/2 minus u to the 3/2, rules of exponents. And then I'm going to do negative. So here, the u gets bumped up to 1, divided by the new exponent, plus, distribute this negative, u to the 5/2, divided by the new exponent, plus c. Final answer is negative 2, 3 minus x to the 3/2, plus 2/5, 3 minus x to the 5/2, plus c. I don't know if you guys remember that kind of scenario popping up every now and then when we did these. 13, I think we're going to run into a little issue here also. We're going to have to get a little creative. So I don't want that 2. But what we could do is we could say there's still going to be this x squared. So we could say, okay, well, 2x equals u minus 4, and then divide both sides by 2, and then square it and replace that with x squared. So this is going to be, there's a 1/2 in front, and then I get a u minus 4 over 2 squared. And then I get u to the 1/2, square root of u. And then I could bring this out in front, it's 1/8. And so now this is u squared minus 8u plus 16, u to the 1/2. So I'm going to multiply this all out. And so I'm going to get u to the 5/2 minus 8u to the 3/2 plus 16u to the 1/2. Wow, this is kind of a lot of work, but I think we're going to pull it off. So it's going to be u to the 7/2 divided by the new exponent, multiplied by the circle, minus u to the 5/2. The 1/8 gets distributed, plus 2 u to the 3/2 divided by the new exponent, plus c. And then we got to rewrite it back in terms of the original variable. So this is going to be 1/4. This is going to be 1/28, 2x plus 4 to the 7/2, minus 2/5, 2x plus 4 to the 5/2, plus 4/3, 2x plus 4 to the 3/2, plus c. Okay, that was a little crazy. Here, I think I'm going to go with u equals natural log x, because in du equals 1 over x dx, that's perfect. This is going to be du over u, which is going to be natural log of the absolute value of u plus c. It's going to be natural log of the absolute value of the natural log of x plus c. No natural log on the inside of that. That's it. Okay, this one, I think we're going to go with u equals tangent, because du would equal secant squared, which is perfect. So it's going to be u du. It's going to be u squared over 2 plus c. It's going to be 1/2 tangent x squared plus c. Now, I get, you know what? Honestly, you could have done u equals secant. Let's see what happens here. And du equals secant tan. This works. So then you would get u squared du, and you get u cubed over 3 plus c, and you get 1/3 secant cubed x plus c. Anybody, oh, those are different. Well, use a little trig identity, and you know, actually, I'm sorry, it wasn't u squared, it was just u. These are the same if you use Pythagorean trig to convert one to the other. Okay, trying to find the original function. So the derivative is the integral of the second derivative, is the integral of sine 2x dx. Now, we could do U-substitution, but I feel comfortable saying it's going to be 1/2 cosine 2x plus c negative. And then we could find the c value right now by plugging 0 in. Cosine 0 is 1. and it should come out to 3. So that means that C equals 3.5 or 7/2. So then the original function is going to be the integral of the derivative, which we just found. Well, I didn't officially write it, I guess. Negative 1/2 cosine 2x plus 7/2. So that will be negative 1/4 sine 2x plus 7/2 x plus c. So we're going to use the initial condition, plug 0 in. Sine of 0 is 0. That's 0. It should come out to 1. So c equals 1. So the original function is negative 1/4 sine 2x plus 7/2 x plus 1. Okay. Similar idea here, but applying like motion to it. Velocity is acceleration of motion is the integral of acceleration, which is the integral of sine 3t, which is going to be negative 1/3 cosine 3t plus c. Plug 0 in. And it comes out to 2. So c should equal 2 1/3 or 7/3. Should probably be easier to work with on the next step. So it's going to be negative 1/3 cosine 3t plus 7/3. Now, position is the integral of velocity, which we just found. Which is going to give you negative 1/9 sine 3t plus 7/3 t plus c. Then we're going to use initial condition. That 0 equals 3. So plug 0 in here. That's 0. That 0 should come out to 3. So c equals 3. So final answer for position is negative 1/9 sine 3t plus 7/3 t plus 3. Okay, good review. Hopefully you're ready for some integration of polar.